All right, we've made it to the end of the week. If this is the first video you've watched this week, you're watching the wrong one. Go back and watch them in order. But anyway, nice job making it to the end of the week. It's springtime, the sun is shining, it's wonderful, right? Speaking of springtime, did you know that the only time that monkeys fall from the sky is during April showers? And you know what April showers bring, right? They bring May flowers. And what do May flowers do? They brought the pilgrims. Get it? History? Anyway, speaking of May, did you know that it's the shortest month of the year? That's right, it's only 3 letters long. I digress. Moving on. Today we're just going to work on review of what we've done already this week. So hopefully if you're understanding it, it'll be a nice, easy lesson for you. But if you needed some help or had extra questions, hopefully this will help with anything that you haven't quite picked up yet this week. So the first thing I want to do is I want to look at this graph and talk about what do we know about this problem. Well, the first thing I know is I've got 2 graphs, which means how many equations are there? Well, there are 2. So because there are 2 equations, we could say that this is a system of equations. What are the 2 types of equations? Well, the blue one we know is a quadratic. So we have one quadratic. And then what type of equation is the red one? Well, the red one's a straight line, so that is a linear equation. So this system of equations is made up of one quadratic and one linear. What else do we know about this? Well, let's go with this. How many solutions does this system have? That's right, it has 2. It has this solution here and this solution right there. Because we know that solutions are the points that they have in common, or the ordered pairs that would work for both equations. And so we know it has 2 solutions. And we can identify those solutions by simply looking at where the 2 graphs cross. So our first solution is -5, 0. And our second solution is -2, -3. So again, that's to recap some of the key points. Systems of equations, we have more than one equation. If it's quadratic, it's the parabola. If it's linear, it's a line. And our solutions are where the 2 graphs cross. We could ask you to graph a system of equations that has a certain number of solutions. So this particular example asks us to write a system of a quadratic equation and a linear equation with only one solution. So there's a couple of key vocabulary words in here. The first one is we know we have one quadratic. So on our graph, what should we see one of? Well, we should see one parabola. So maybe it's right here. For the sake of this problem, it doesn't matter where it is, we just have a quadratic. We also know that we have a linear equation. Okay, what does a linear equation look like? It is a line. We also know that there is one solution. So if there's one solution, how many times will the line that I'm going to draw, how many times will that line touch the parabola? Well, 1 time, because there's only one solution. So I might draw something like this. And so my solution, right, my one solution is this point right here, which looks like it's about 1.5, 2, right? So any picture that I drew that had one parabola, one line, where they only touched in one spot, that would work for this problem. This one says to graph a system of 2 quadratic equations. So if it's 2 quadratic equations, I know I have 2 parabolas. And it says it's going to have no solutions. So again, we know that a solution to a system is the ordered pair where the 2 graphs cross. So if this particular system has no solutions, that means the 2 graphs never cross. So I could do something like maybe a graph up here and a graph down there. That would be no solutions. You could get even more unique. You could do one that opens up And then you could do a second one that also opens up, but is skinnier, right? So those two would also never touch. That's just a second example. Either of these graphs would work for this problem. A majority of the week, though, we spent actually solving systems of equations algebraically. So going back and using our, what we do to one side, we do to the other. And then also in this process, because we have quadratics, we get to practice the quadratic formula. So this first example is one quadratic and one linear. But we know that both of them are y equals. So I can take what y equals and plug it in for y. So I can rewrite this as 3x squared plus x minus 3. And then it equals negative 4x minus 7. And again, at this point, we've gotten rid of the y and we're just solving for x. To solve for x, if it's quadratic, we need to get one side equal to 0. So I'm going to leave my positive 3x squared here, which means I need to make this side 0. So I'm going to add 4x to get rid of the negative 4x. And I'm going to add 7. And we get 3x squared plus 5x plus 4 equals 0. This looks familiar. We might have done this on one of the other lessons. But anyway, we can use the quadratic formula. A equals 3, B equals 5, C equals 4. Plug it into the formula. X equals negative b plus or minus the square root of b squared, which is 25, minus 4 times 3 times 4, which is 48, all over 2a, which is 6. So we get negative 5 plus or minus the square root of negative 23 over 6. Ah yes, we have done this one before. If our square root is a negative, how many solutions do we get? We get none. No solutions. All that means in context of this problem is that there is no x value that we can plug in to both equations and get the same y. It also means that on the graph, these two graphs will never cross. Okay, another example of one linear and one quadratic. I can take my first equation and substitute it in for y of the second equation. 3x squared plus 14x plus 7 equals 2x plus 22. I want to keep my x squared positive, so I'm going to make this side equal to 0. Going to get rid of 2x, subtract it on both sides. Get rid of 22, subtract it on both sides. That gives me 3x squared plus 12x minus 15 equals 0. And I'm going to have some big numbers on this one, but that's fine. If you need help with the bigger numbers, just use a calculator. Our A is 3, B is 12, C is negative 15. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. You've missed that. I know you have. All right, so we get x equals negative 12 plus or minus the square root of 144 plus 4 times 3 is 12. 12 times 15, I believe, is 180, all over 2 times 3, which is 6. 144 plus 180 is 324. Again, big number, but if I take the square root of 324, it is 18. So the square root of 324 is 18. And now to get my x values, right, it's x equals, I can do negative 12 plus 18, which is 6 over 6. And I can do negative 12 minus 18, which is negative 30, all over 6. So my two x values are 6 over 6, which is 1, And my second x value is negative 30 over 6, which is negative 5. So hopefully you remember that we're not done yet. All we've done so far is find our x coordinate, but we know that the solutions are going to be x comma y and x comma y. So how do we find the y coordinates? We take the x and we plug it in. You could plug it in here, but if we have a linear equation to plug into, it's going to be typically easier to plug into. So if I plug in 1 right here, that's y equals 2 times 1 plus 22, which is 2 plus 22, which is 24. So one of our solutions is an x of 1 and a y of 24. Our second one, I'm going to take negative 5, plug it in for x. So 2 times negative 5 plus 22, which is negative 10 plus 22, which is 12. So we end up with 2 solutions. That means that this line crosses through that parabola in 2 places. It crosses through at 1, 24, and at negative 5, 12. Moving on to 2 quadratics. We know that if we were to graph these, it would be 2 parabolas. But we're going to try to find out if they cross, and if so, how many times and where. Same steps. I'm going to take one equation and plug it in for the y of the other. It's called substitution. 2x squared minus 3x minus 2 equals x squared minus x minus 3. Now this one I have x squared on both sides. And again, I always want my x squared to be positive. Makes the problem easier. And it keeps it in standard form. We want a to be positive. So I'm going to subtract my smaller x squared, or get rid of my smaller x squared. So minus x squared from both sides. I also need to move that, so I'm going to add x. And I need to move the negative 3, so I'm going to add 3 to both sides. And we get x squared minus 2x plus 1 equals 0. We have standard form, so now we can identify our A, B, and C. And we can plug it into the quadratic formula. X equals negative 2 plus or minus the square root negative 2 squared minus 4AC all over 2A. So x equals negative 2 is positive 2, plus or minus the square root of negative 2 squared is 4, minus 4 times 1 times 1, all over 2. Well, what is 4 minus 4? Calvin, what's 4 minus 4?
0.
0, very good. See, math so easy, a second grader can do it. All right, so we get square root of 0, and the square root of 0 is 0. So we really get 2 plus or minus 0 over 2. But what's 2 plus 0? Calvin?
2.
2, very good. What's 2 minus 0, Calvin?
2.
2. So it's the same thing twice, which means we really just have 2 over 2. So our only x value is 1. We're going to get one solution. That one solution has an x value of 1. Now we just need to find the y value, or the y coordinate. So we're going to take our x of 1 and we're going to plug it in. I can plug it in there and there. All right, I could also plug it in there and there instead. Either way, same answer. Pick whichever one looks easier, or try them both and make sure you get the same answer for both. But if I plug it into this one, I get y equals 1 squared minus 1 minus 3. So that's 1 minus 1 minus 3, which is 0 minus 3, which is negative 3. So by plugging 1 into this equation, we got that the y coordinate is negative 3. Again, big picture, that means that these two parabolas intersect one time, and it's at the ordered pair 1, -3. All right, last question for the week. One more system of quadratics. I'm going to take one equation, plug it in for the y of the other. -x squared minus 8x minus 7 equals x squared plus 4x plus 3. What do I want one side to equal? 0. Do I want my x squared to be positive or negative? Positive. So I'm going to get rid of my smaller x squared. So I'm going to add x squared, and we'll make the left side equal to 0. I need to also add 8x to both sides. And then I need to add 7 to both sides. And we've now made one side equal to 0. The other side is 2x squared plus 12x plus 10. So we have a quadratic equation in standard form, which allows us to use the quadratic formula. A equals 2, B equals 12, C equals 10, x equals -b plus or minus the square root b squared minus 4ac all over 2a. Again, we simplify. X equals -12 plus or minus the square root of 144 minus 4 times 2 is 8. 8 times 10 is 80. All over 2 times 2, which is 4. We then simplify our square root. 144 minus 80 is 64. And the square root of 64, we can simplify square root of 64. Square root of 64 is 8. So I'm going to replace that with 8. I could use the Dorito chip to simplify here, but since we don't have any square roots, I'm just going to add and subtract to get my 2 x's. So I'm going to do -12 plus 8, which is -4, divided by 4. And I'm going to do -12 minus 8, which is -20, divided by 4. So we get x values of -1 and -5. So again, we did all that work just to find our x coordinates. We know that one ordered pair is going to have an x of -1, and our other ordered pair is going to have an x of -5. Okay, our last step is to get the y coordinates. We need to now take our x and plug them in. Again, it doesn't matter which one we plug into. To me, this one looks a little bit simpler because I don't have all those negatives. So I'm going to plug into this equation. Y equals -1 squared plus 4 times -1 plus 3. That's 1 minus 4 plus 3, which is -3 plus 3, which is 0. So if my x is -1, my y is 0. For my second solution, I'm going to do the same thing, but I'm going to plug in -5 for my x's. So I'm going to plug in -5 in both of those. -5 squared plus 4 times -5 plus 3. -5 squared is 25. 4 times -5 is -20. Work from left to right. That's going to be 5 plus 3, which is 8. So our two solutions, or the two places where the graphs cross, are going to be -1, 0 and -5, 8. Hope you guys are doing okay with these lessons. Again, you could always use Desmos to find the answers, but we really want to get this extra practice with solving equations, especially with the quadratic formula. And as my son would say,
that was easy.
that was easy. See you later.